Greetings, welcome back to ECD Laboratory, second semester Diploma in Electronics and Communication. We are in this experiment. In this session. I'm going to explain about experiment number 2. In experiment number 1, we are able to find the value of resistor, capacitor, inductor with the help of color code and with the help of the character or number displayed on the printed on the body of this devices. See, but in this experiment we use the actual practical value of those devices with the help of the multimeter and LCR meter. This is the experiment, that means verify the value of passive component using the multimeter and LCR meter. And there is a theory section also, session number 2. I had explained about how to use the multimeter and capacitor LCR meter to measure the different value of electrical parameter, and how to do range selector and how we have to connect all these things. I had explained in a theory session. This is the lab session. In this lab session we have to measure the three devices actual value. One is resistor, capacitor and inductor with the help of multimeter and LCR meter. See, first is of finding the resistor value. The resistor we already know how it will look like. This is the resistor, have a two terminal, have a color code, and this color code is represented as a color table. With that we will be able to calculate the value. This we have done in experiment 1. In this experiment number 2, we will take the same resistor and we will connect through multimeter or LCR meter. You can take any of this one. Let's take a multimeter and connect the positive to a V and ohm section and black to COM. See, like this we have to connect the probe, multimeter probe onto a COM and V or ohm mode. And next thing is to set this dial knob into an ohm section. There is a ohm have a different range. We need to select the right range, otherwise multimeter will not be able to display the actual value. See, we have to select the proper range. See, after selecting the proper range, place this LED, two LED, one is positive, another negative LED, into a resistor 2 terminal. It displays the value. After the displaying the value, after finishing of the experiment, we need to turn off this meter, because meter are operated with the help of battery. See, if you keep on placing in on position, the battery will get dry out and meter will not give accurate result. For that, for the longer life, we need to switch off the meters or the devices if we completed the experiment. See, this is the procedure we followed while measuring the resistor value with the help of the multimeter. See, while if you follow the same procedure, and the display section of the multimeter displays like this. See, what actually how to read the digital display. So this is actually a challenging task. See, if it is 1 ohm, means it's a simple 1 ohm. There may be some digital display 1k ohm. That means k means it's a 1000. You need to multiply 10 raised to the power of 3. 10 raised to the power of 3 means it's a 1000. This actual value is a 1000. See, 1 m ohm. So many people will do mistakes while reading the value. They will forget about this specific kilo or mega. This is very important. If they forget to write m or k, then the value will be differences. 1 mo means 1 mega. 1 mega means it's a 10 raised to the power of 6. 10 raised to the power of 6 ohm. So this is the reading of a digital display. And there are some other example, 1.18 kilo ohm. See, here you can observe auto. What is meant by auto I will going to explain in coming slide. Its actual value is a 1.18 into 10 raised to the power of 3, means it's 1000. We need to multiply with 1000. The actual value is a 1180 ohm. So this means 1180 ohm. So this way we have to read the digital display. Sometimes some digital displays like 0L. This indicates infinite. This means out of range. If the resistor while selecting the range knob, here in this previous case, if the range knob is selected 20 kilo ohm, but our actual resistor value is at 20 mega ohm, during that time it will display like this. OL means it's out of range, or it's a, there may be a infinite value. It's like this, means out of range can be with display like 0L, or some one it will be 1 or OL. It's a overloop, or a couple of a dash line indicated that the range is set low. Whatever the range we have selected, it's low. Actual device it's having a higher range. That is the representation of a digital meter reading, and this is a warning indication. We should alert when we get this kind of reading in our digital meter. And there is a range selection as a two option. One is auto, another is a manual. See, if you see here auto, see, auto means it's automatically they select the range. Even multimeter have capability to selecting auto range. So this is about higher end version of multimeter. In this one, it's very easy to use this. Student can be able to very easily, he just need to connect this two wire and placing this other end of the wire to any devices. He will set the knob either to ohm meter or to voltmeter or to ammeter, and just measure the reading. It will automatically select the range and it will display. But while manual select, whatever the low end of multimeter doesn't have auto select, they have to use the manual range selector. See here, you can see if you select ohm meter, the range has to vary from 200 to 2m. User or who are using the multimeter, they have to change this range knob as per the device value. See, I have given one best example how we can use this manual range selector. Means whenever you get a 0l, that is infinite value, you just keep on increasing the value, increasing the range knob, then you one point you will get the actual reading value. See, this is a trial and error. Manually means you have to do trial and error option. You have to select the right range only, then only you will get the actual reading. Otherwise user will not be able to measure the value. See, this way we need to select the range. And there is a, in our experiment number 2, you have to take any 5 resistor different devices, and you need to mention the band 1, band 2, band 3, band 4 numbers, and you need to calculate it with what we explained in experiment number 1. So this is a calculated value based upon the printed on the color code value, and you need to use the same resistor, and with the help of ohm meter you can measure the reading, and whatever it displays on the meter reading you have to note down. And ohm meter value, sorry, this is the calculation and resistance value in the ohm meter. Whatever the final resistor calculation you have to note down here, and ohm meter value with the help of multimeter measure the resistance and note down here, and you need to find out how difference is it. See, like this you have to do for it 5 different type of resistor, and you have to take some multiple resistor 3-4 combination and connect this. So this is the activity you have to do it, and this gives more knowledge. This is not in your syllabus, but you have to go through this. You have to take the 3 combination of the resistor, name it as R1, R2 and R3, and place it on to a breadboard connected in such a fashion. This fashion we call this series combination. Then you know this value of R1, R2, R3 with the help of, see, you take the same resistor, whatever 5 resistor, and you know this value, you note down the value R1 and R2, R3, and with the multimeter you have to measure the resistance across A and B. You note down here resistance across the AB. So this is a actual meter reading, and there is a formula. You need to add all these 3, R1, R2, R3, whatever the value you just recorded here, and observe what actually is this. See, this is a observation whether both are equal or not. This you have to conclude it, and you have to derive an expression. See, you need to conclude it. Means if it is a series combination of the resistor connected in series, the effective resistance will be addition of this each resistor. See, that gives the effective resistance. That is the conclusion you have to derive from this activity. You have to tell whether it is happen or not. And there is a parallel combination also. You take 3 different combination of the resistor, and you know the value. How to calculate this 3 resistor value? Either you calculate with the help of ohm meter or through color band and note down. And resistance across AB, you use the multimeter and set the ohm mode and measure across AB and note down here. And this is a formula, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Use this formula and calculate it and note down here, and you need to derive a conclusion. So this is the activity you have to carry it out. And there is a second experiment is to measure the value of inductor. How we will going to measure the value of inductor? Take any inductor and take a LCR meter. See, you have to use the LCR meter. With the help of multimeter we will not be able to measure the inductor value. You should be very careful. Inductor means you have to go with the LCR meter and switch on the LCR meter. It should display 0, otherwise you have to reset, and you need to set the dial knob, LCR meter dial knob into L section. The L indicates the inductor. This is the second procedure. And third one, you need to select the range. You have to select any of this range. You have to start with 2 millihenry, 20 millihenry, 200 millihenry, 2 henry, 20 henry. So these are all the different range. You can select any one range, and you have to connect positive and negative. It will display the actual inductance value across the display section. You just note down this. So this is the way you can measure the inductance value. And see, like this you have to take different inductor and note down the digit, whatever the it is represented, digit 1, digit 2, and multiplier and tolerance and calculated value, and what is the inductance value as per this calculation, and whatever the LCR meter reads, you need to calculate here. This is the first experiment. And same thing you have to do a activity, series combination of inductor and parallel combination of the inductor. In series combination you have to take 3 inductor and connected in series on a breadboard, and you should note down the inductor 1 reading, inductor 2 reading, inductor 3 reading, and you have to use the LCR meter and measure the inductor across AB. That reading has to put it here, and there is a formula. With this help of the formula you need to find out the value, and you need to derive a conclusion saying that if 3 inductor connected in series will be added each and gives a effective inductance. That derivation, that conclusion you have to come up with this activity. And parallel combination, if 3 inductor connected in parallel combination, how it will going to behave, that you have to derive the with the help of this table. This is the activity you have to do it. And next experiment is to calculate the capacitance value with the help of LCR meter. In this one you have to place, you have to take any capacitor. You have to take electrolyte capacitor, ceramic capacitor, and MLC capacitor, polystyrene capacitor. The capacitor have a printed value, that is called electrolyte capacitor. Capacitor have a color code, it's a polystyrene capacitor. And capacitor have a number displayed on the body, that is a ceramic capacitor. You have to take the 3 combination of the capacitor, and you should measure the value, and you need to calculated the value as per the experiment number 1, and you need to verify whether your calculation has meet the practical value. That is the conclusion you have to derive from this experiment. You place this capacitor on any breadboard, and set this LCR meter into a capacitor knob, that is a C knob, and take the 2 leads of this LCR meter. One is for positive, another is for negative. Electrolyte capacitor has a polarity, means positive has to go with the positive polarity and negative has to go with the negative polarity. And you just hold for a few seconds, you will get the actual reading. Here it's mentioned as a mu f. Mu f means it's a microfarad. This value and the printed value, you should be verified whether it's showing the same thing, whatever the printed value and LCR meter C values getting same, that you have to get conclusion. So this is a simple table. Capacitance value printed on the capacitor body in the microfarad electrolyte capacitor. You have to place it here, and with the help of LCR, whatever the value measured and what is the voltage range is mentioned. And finally, with the some observation, you have to compare these two, and you have to conclude your result. And there is a disc capacitor or ceramic capacitor. Disc capacitor and ceramic capacitor is a digit 1, digit 2, digit 3, and tolerance. You need to do a calculation, and calculated value place it here in this column. And with the help of LCR meter, you need to compare, you need to record the value, and you have to compare these two. And there is a polystyrene capacitor, it's a band. You have to use the color band, band A, band A, band D, and band T, it's a tolerant. You need to use the calculation, and calculated value you have to place it in this cell. And with the help of LCR meter, you need to place it here, and you need to compare last. And at last you have to do activity. You have to take 3 capacitors and connected in series combination like a C1, C2, C3. The C1 value place here, C2 value place here, and C3 value place here. And you need to use the LCR meter in a capacitor measurement and calculate the capacitance across the AB and find out here. And with the help of this formula, you need to calculate it here, and you need to compare whether it's both are same or not, and you have to get a conclusion. And same thing, if this 3 capacitor are connected in parallel, how it will be reacted, that you have to do it in this experiment, and you have to get a conclusion. Thank you.